you heard of it before, or you just see it on Meetup and decide to show up. That's basically it. Women Who Code, great. Yeah, thank you very much for coming. We'll get started in a couple minutes here, but just a quick kind of overview. Google development groups meet not just here in the United States, but all over the world. There's a huge number of resources available to people that are interested in learning more about Google development platforms. A huge number of these groups in every major city now. I think we started around a year and a half ago with like 6 people at Goat, and now there's almost 60 people, 70 people in this room. So it's really great to see you all here. So thank you for coming. Chuki is our organizer, or one of our 3 organizers, and she really spearheaded tonight's ensemble.
Yay, all right, thank you for coming. I have to do all the announcements.
Great, yeah, announce
the
away.
stage from you.
I'm not good at announcing before.
So thanks for coming. We actually have a lot of people. We just that we have to move to this bigger room. So sorry, don't have to wait, but we have to wait for the previous meeting to go out so that we can use this room. And so today we have Stacy, and that's because she approached me and said, hey, I can give a talk. So if anyone has something that they want to share with the community, please let us know. You can talk to me, talk to Chris, or send us a note on the Meetup group. We're always looking for people to come and talk to the community. And in the same spirit, there are actually other events that you may want to know about. So today's talk is about data science, and that's actually another talk hosted by Women Who Code next week on Wednesday, the 6th of May in Denver. It's called A Data Scientist's Journey to Understanding Biological Pathways. So Women Who Code meet up, meaning that only women attend. So that one may be for just half people. There's another one which is actually not data science. That's something that I'm interested in, which is actually mapping technology. I don't know if people are using that kind of thing. So next week, Map Time Boulder is doing a special map to help the Nepal rescue efforts to basically have more accurate map data. That's Thursday in Boulder on the 7th. And then the week after is Boulder Startup Week. There's a lot of stuff going on. One of them is analyzing, which is a data science thing. Apparently someone likes it. I don't even know how many things there are for Boulder Startup Week and how many of them are open to the public, how many you can ticket for, but just go find more information yourself. And then finally, much later is Google I/O. Some of you may be flying all the way to San Francisco to attend. If not, we are doing a live streaming from here. There are 2 days of Google I/O, so May 28th and 29th. We are just doing the first day. But then you can come and listen to the keynote. We'll put some of the details on meetup.com later. And then one final thing, which is there is a Android training bootcamp that is done by New Circle, which is a company that's based in San Francisco. But one of their trainers is based in Denver, and he really wanted to bring it to Colorado. And he kind of needs to have some basic level of interest. So I just kind of want to know, by the show of hands, who will be interested in attending an Android bootcamp? Yeah, meaning like a 5-day, like a full week of Android, learning how to, from zero to learning how to go on Android. Okay, so he sent me an email that I can forward it over to the group. Then you can get in touch with him. And then at this point, you're not actually paying yet. You're just saying that I'm interested. So if you have enough interest, then you can convince the headquarters so that, hey, let's do it in Denver. So cool. So I'll send out all those information after this. Any other announcement? Anybody else wants to share something interesting happening in the community? All right then. So without further ado, we will turn the stage over to Stacy.
Thank you. Thank you guys very much for coming out. One more announcement, I'm actually the lead for Women Who Code's data science group. So you're welcome to come join us and learn more about analytics. Also, with Women Who Code, men are allowed to attend meetups, but we focus on women, and they will be, you could go as a guest if you wanted. We definitely focus on women. Oh, I love it, male jump. Let's just get. So apparently, GJ Patel and Mr. Davenport believe that data science is the sexiest career of the 21st century. And today we're doing spreadsheets, so we're about the sexiest socks with sandals. And you know, you might really love your tool stack. And if you work with some big data analytics tools and services and and they work for you, that's really great. You know, I didn't mean in my my intro or in my description of this talk to put these down at all. I love to geek out over this stuff. You know, but the reality is when you're a data scientist, you need to focus on your business. And this is where I work. This is Denver Human Services. And so my hope when I go into work every day is that I can leverage data to help make people's lives a little bit easier on, you know, our caseworkers, the people processing information for those who need food assistance or housing support or, you know, temporary assistance for needy families. So I've heard a lot that, and this is Drew Conway's Venn diagram about data science, and this has been thrown around a lot recently. I don't know if you guys have been to some other data science talks in the area, but data science is supposedly this like really perfect integration between hacking skills and math and science, substantive expertise, you know, and the data scientist is supposed to sit nice in the middle. So, hi, I love your shirt on MailChimp is your lead data scientist, Sean Foreman. You know, and here's the reality of what you're doing as a data scientist. The reality is that you're spending a third of your time trying to figure out how to use data to solve problems. You're spending a third of your time up to your elbows trying to clean that data and scraping it out of PDFs and all kinds of crazy forms. A third of your data, hunting down the data that's logged in some strange way, applying developers with drinks to get it into your big data store. And actually, I'm not a statistician. I don't do a ton of analytics. I'm actually that person that you would apply with drinks. I'm a database developer. So, and then you spend just a tiny, tiny, tiny little percentage of your time actually training models. So 80% of data science jobs go unfilled. And it's probably because of the mythical creature in the middle there that you will almost never find. You probably don't even need that mythological creature. Because all you really need is to be able to have somebody to bridge the gap between complex analytics and the dreams of your company leadership. Oh, subject matter expertise. So I went ahead and pulled a bunch of data science positions around Denver to look at what they were looking for. And the top three, SQL, Python, R. The fourth one is definitely more statistics. Hadoop is, you know, classic big data. But are those top three small data? I think companies are getting wise to the fact that 10 megs of really good, clean data in a nice format that you can do a pivot table off of will give you a lot more information than terabytes of unstructured garbage like that selfie you refuse to delete. So this quote is a little bit old. Companies are getting a little bit better about how to use how to use analytics and how to leverage more data. But I can tell you that I've talked to even a few people in this room who do analytics for a living, and they will tell you secretly, I use a lot of spreadsheets. I put lots of things in Excel. So even if they have tools available to them, it's sometimes nice to just be able to look at your data. So the same types of things that plague big data also plagues small data. Yeah, yeah. I mean, first of all, you have to know what you're looking for and where to find it in order to get what you're looking for. And second of all, you could have a really, really beautiful correlation that is absolutely meaningless when it comes to predictive ability. Yeah. I swear to you that Georgia did not pay me to put up the slide. So she's the head of our lean team at Denver Human Services. And I just want to say that this is not my first merry-go-round on analytics. And where I was previously, I knew nothing about Lean or Six Sigma or process improvement. And I was expected to. So essentially, if you work in this field, if you're looking at going into analytics, I would strongly recommend that you look at process improvement as well as how to do analytics, because essentially you're going to be asked to participate in process improvement. And the reality is that not everything is solved with a technological solution. Lots of things have to do with the way that things are structured or the way that you're going about your internal business process. And so having that knowledge ahead of time would be really, really helpful in making your employer know your value. So what the heck is my deal with spreadsheets? Well, no, the reality is no one's going to hurt your business because they downloaded fancy software and they produced a really cool Delphi graph, or they figured out, some deep dark secret about your data. You need to use use data to leverage your own business, to make your own processes better. You might be able to do some market research. You might be able to do, I'm hoping to maybe show you a little bit of that, provided that I can get Google Sheets to pop up on the screen. But you might be able to look at, clusters or networks or relationships with your data, but let's face it, you're not really going to have this great, huge breakthrough as a general rule. IBM has Watson. They throw Watson all over the place when it comes to predictive analytics, and they can't seem to stem their sales losses. So it's one of those things that it's just really easy to get your hands on. It's really easy to see your data, and figure out what's going on. All right. So let's get to it. I just want to quickly make a little note that, a lot of the things that you do in spreadsheets are easier and they are easier in code, and that's true. But I'm hoping that maybe I can show you some really basic stuff, and it will be super basic, but the reality is that you're not born knowing how to use spreadsheets. So I'm hoping that maybe I can help show you some tricks to make your life a little easier. All right. So let me see if this will play and I can get to an actual spreadsheet. Because I downloaded a good one here. Let's see. I downloaded my employer City of Denver's open checkbook. To play with. So, let's see. See if we can get this guy there. And if this is too weird, we can always go back to the slides. Yeah, and of course, one of the other limitations that you have with spreadsheets are that in so many rows. So I only downloaded 2015, just to be fair. So this is not going to want to play. So we'll go back. We'll go back and I'll just talk you through it. I'm sorry, guys. Yeah. All right. A couple of things, to look at your data just to get started with it and to start playing is navigate quickly using either the control buttons or the command button if you have a Mac, using the up and down arrow so you can see how many lines you have. So when you're dividing something and all of a sudden you have more on your numerator than your denominator, you can catch those errors pretty quickly by knowing how big of a population you're starting with. One of my favorite tools is conditional formatting. You can go ahead and select a conditional format so that you can change the color of your data based on whether or not it's above a certain number, below a certain number, contains a certain string, so that you can float, and then you can also sort by that color, so you can float all those things to the top. So say I'm looking for Shell gas stations in this huge spreadsheet, I can use conditional formatting to look for Shell and to just move those guys right up to the top. I can also use a color scale where there's a gradient of the color, a darker green to a light green to a white, to look at my midpoint to my midpoint, and my midpoint to my max point. It's also useful to help you look at the data types that you have. If you are having a hard time in another tool getting your data to play nice in the sandbox, let's say you're mapping and and you have like the address number on a line and you're trying to figure out why the heck isn't this guy working, you can look at your data types, change your data types, and re-export if you need to. VLOOKUP, vertical lookup, links spreadsheets together, so you can be on a separate spreadsheet and say, say my first spreadsheet was was like a list of vendors, and my second sheet had the cost for their merchandise. So I could use a VLOOKUP function just to go ahead and quickly link those things together, so you have some relational ability. So, I just recommend that you go home and you play with some data sets. There's lots of free data online. Go Code Colorado has lots of data sets. Of course, we have Denver Open Checkbook. you go ahead and start looking at some of the formulas that I was hoping to bring up for you, but you know, to try to get to know your data set. If you're using a formula and you get a value, pay special values to get that value into another sheet so you can work with it. Pivot tables. Pivot tables are similar to the group by or aggregate functions in SQL, and similar to a crosscat function in a lot of BI tools or a 2D OLAP. There's a rap online called Pivot Tables Make Everything Just Right, and it's terrifyingly accurate. All right, so to back up a little bit. There are 3 types of analysis that that you can start to do with your data. Your descriptive analysis is exploratory. It's your data visualization, your mapping, your networks, you know, all of the things to try to get to know your data. And the reality is that a lot of analysis, the past behavior is predictive of future behavior. So getting to know how things worked in the past will help you in the future. Getting to know your business trends over time. How come we have so many Med applications this month? Well, it's open enrollment for Affordable Care Act. So, and then you can move on to predictive analytics, where you have forecasting, classifications, associations. You know, you can predict new outcomes. And then you have prescriptive data, which is decision-making trees, Monte Carlo simulations. So to back up on some of the things that you can do with your data, you know, and you'll have to forgive me if you already really know Excel pretty well, because I'm surprised sometimes when people ask me how to do something and it's just as simple as like freezing a pane. You're just not born knowing this stuff, so I'm gonna go through a little bit of it with you. To freeze your top row, you highlight the row, click view, freeze one row. And that way you whenever you scroll, you know what you're dealing with. I mean, the data set that I was going to show you today, working with it, was 50,000. 480 rows. And if I wanted to figure out who paid the most or who was paid the most on a contract, you know, you can sort those values, or look at, say, everybody who was paid more than 10 grand. You know, and actually the top payee was Metro Wastewater. And then when I was scrolling through the data sets, every 2 weeks, the police and fire pension got to get paid. So, so it's kind of interesting what you can look at and what you can see when you start to actually work your way through a data set. Pivot tables are pretty, you know, have to figure out. All right, so you have your data. You know, and you can pivot this value so that you can see you know, the total sum of what this particular payee was paid. So anyway, pivot tables make everything just right. Linear regression is another really simple tool to learn, and I say this and it makes statisticians want to kill kittens, but it's really easy to learn. Yeah, you have these plots of data, and you look for your, and you can literally just click on the advanced tab in Google and find your line of best fit and your value of how close that matches, or your R value. And then the other linear regression. One of the deadly sins of linear regression is extrapolating. One of the things I'll implore you to try to get to know is a tool called Solver, which is really cool. It's the same company that made this tool for Excel also made the same tool for Google Spreadsheets. And you essentially you can put in a bunch of data, and it will figure out what the best way is to use the constraints that you have. So my evil little plan was to try to figure out how many cameras I could put out and how much money I could make in traffic tickets. If I put in an extra 50 red light ticket cameras, and it'll tell you, what type to use to get the most bang for your buck based on your constraints. So if I had 10 cameras that could look at red light running, and another 20 that could look at speeding, and they each paid out different amounts of tickets, it would figure out the right combination to get me the most revenue. Which type of camera to put out. And it's neat to go ahead and let Solver decide those things, and that's kind of your first little introduction into machine learning with, machine learning and forecasting. And a little word on machine learning, because I found out recently that when I use the term machine learning in my office, that it creeps people out. Machine learning is not Skynet. We're not teaching the computer how to think for itself. We're giving it a data set. We're helping train it so that it can make better decisions and use some predictability using algorithms. And you can start to play around with this using Solver and the Power BI tools and Microsoft Excel. Yeah, so whole thing is a little bit of a lie. I don't know how many of you played Half-Life, but there's a tool called Google Fusion Tables that you should really get to know, and it's very easy to use. Fusion Tables. So my group won the Go to Colorado Data Jam using formatting data and Fusion Tables. They're very simple to use to get to know. They have great tutorials. They have these templates that you can download. I don't know how many of you know about Google's templates, but if you're curious about, I don't know where to begin using Solver, or I don't know where to begin, drawing a neural network, Fusion Tables will literally walk you through it. The templates are really amazing. And that's all I have. Without being able to demo. Let me see if I can get it to play. Also, just some resources for you to get going. Coursera has these really amazing data science classes through Johns Hopkins, and they're free, and they will literally hold your hand. I mean, as much as it can possibly get. They're really great. There's an organization, if you're involved with nonprofit data or government data, called Do Good Data, that has some great webinars. And MailChimp's chief data scientist, John Foreman, has a great book called Data Smart to help guide you into starting to learn some analytics. So let's see if I can. Data Smart, I think, was $30. Do Good Data has some free and some paid webinars. Coursera is completely free. Speaking of Coursera, there's also another program that I really highly recommend called Programming for Everybody on Python. The instructor has a Coursera tattoo. That's how hardcore he believes in it. He's a professor at University of Michigan, and if you tweet him, he will literally answer you back. He's a really, really cool guy. So I mean, let's see if I can. Yes, Coursera Python, Programming for Everybody. Let's see. Sure.
So I'm fairly comfortable with so when you get started, do you just save a lot? Like, kind of, let's just see what happens here, and I'll just save this side. Like, you know, is that kind of your process? Just kind of try and see what else we can sort.
I just, definitely. I also have a tendency to be kind of save happy. So sometimes I'll do a save as, so I have another copy 2 or 3 or something and just delete.
You just try to keep track of the different variations.
Here, and I think that's really the only way to learn this stuff, is to just dive right in. You know, but that's a great question. I mean, yeah. See if we can get this guy to. Yeah, this is not. Weird. I will know better next time. Does anybody have anything that they have used or learned about on their own journey that you'd like to share?
My name is Ben. I program almost exclusively in R. I use spreadsheets a lot. R has methods for importing tables and various functions. It's all that but I often find myself copy pasting something into a spreadsheet.
Thank you. So R is getting a little better. R has some really wonky syntax. I don't know if you guys have been working at all in R, but it can get a little frustrating from time to time. It is getting better though, as far as you being able to tell it to like censor over a certain amount, or it's starting to get some of those data mining tools so that you don't have to rely on Python or spreadsheets so much. But there's absolutely a case where it can just be super wonky. So, yeah, in doing this type of work, I was looking at some cases of people who've done data science that is really not so great. for instance, Netflix has had the Netflix Prize where they offered $1 million to people to come up with an algorithm for predicting what your next favorite movie was going to be. So in the process, they, number one, ended up with a model that had to be spoon-fed and was almost unusable. It was too ridiculously complicated. And the other thing that happened was they outed people who lived in small towns who maybe were LGBT or they had only the description that would meet that one person in that one zip code. You know, so I'm a big proponent of open data and open government, but you have to be really careful to be smart about those things. And, you know, just speaking as someone in this field, I hope that you guys, you know, take away from that and are smart about how you put out data also. I would, you know, it was funny that I was talking to some people at the data science study group for Women Who Code, and it turns out that about 5 of us in the room, including myself, are former chemists. So I think that's like this weird transferable skill set. And I usually go off the rails on the crazy train when people use science terms in a way that's not really science. Like, I'm a catalyst. But, you know, I'm a catalyst for change, yeah. But data science is one of those that doesn't annoy me as much. And I think one of the reasons for that is that we both professions suffer from the same kind of common misconception, which is, you know, I hear this a lot. Well, it's true because the data says it's true. It's true because the science says it's true. And then you end up with walking away, you know, talking to the general, when you're talking to the general public, they end up walking away going, science can't make up its mind. One minute you're telling me wine is good for me, and the next minute you're telling me wine is bad for me. And at what point is what is coming out of your mouth actually true? And one thing to know is that your data, as well as your science, can show things that are actually true. But they are not true for all people under all circumstances all the time. You know, and so I think that's something important when you're talking about communicating data.
Is that also part of, I mean, I'm just learning statistics.
Uh-huh.
And it's just like, if you look at the data in the right way, you can get it to say almost anything on the spreadsheet. At a company, you know, a company presentation, but you want to make sure it's really true.
Yeah, that's absolutely a good point.
False positive.
Yeah. So you have, I mean, that problem of false positive, false negatives. You have the problem of shrinking down cutting your axes off, your y-axis off, so that when your graph is shrunk, it looks like there's really a correlation that there really isn't. I run into a lot of people that want to add decimal places where they absolutely should not be adding decimal places. If your numerator and denominator look something like this, then you can't do something like that. You know, you do not own that many significant figures. Yeah, and especially when you're using something like this to create a trend when there's no trend. So I appreciate you guys letting me go off script since I can't demo what I really wanted to for you guys. So thank you. Google Sheets is very similar, and Google Sheets for a while was getting a pretty bad rap, and because they weren't catching on to some of the things that other spreadsheet programs were catching on to, like LibreOffice and Excel, but they are now. They are absolutely listening now.
I just wanted to say it's a coincidence. I'm in a business intelligence class right now in grad school. And the article we had to read for today was about pervasive BI and Excel, and how Excel is this great tool if you want a whole organization to be BI because it doesn't have to just be the technical experts, but it could be like, you know, the majority of your organization that knows something about it.
Yeah, and that is such an incredibly great point too. I mean, a lot of people think that if they possess this great knowledge and they silo that, then that means that they have this job security. And so a lot of people in analytics or business intelligence will sometimes create things that are way overly complex, that are really difficult to teach to other people. And to me, that is the most ridiculous, boring form of job security imaginable. So, I mean, no, you're absolutely right. If you want to create a data-driven organization, it's behooves you to try to put the tools in the hands of the people that you are trying to drive also, and working with them so that they see your data as a tool and not a weapon. And that's something that happens to organizations all the time. You have these reports that you pump out and people put them up as a wall of shame, you know, point their finger at you that you're processing too slowly. Yeah, it doesn't really give them a chance to figure out how to improve.
What steps do you recommend to make research?
To make research repeatable, we're working through that right now. Definitely storing the queries that you used, cataloging all of the assumptions that you took, keeping track of why you did the steps that you did, and making sure that you can pull that data in the same way. And snapshotting and storing data is something I do a lot also. Oh, wow. Yeah.
So you mentioned at the beginning, 80% of users don't build. What do you think is the expectation that somebody puts a position out? How do they measure the effectiveness of data scientists? Is it all about cost savings, or did this and then they say this much money, or
How are they cataloging that?
they just feel like
I just
feel like they just have to have it because
yeah, they feel like they just have to have it because they think everybody else has it. I run into that a lot. There was a local company that I recently saw a job description for. It was one of the ones that came up when I was mining through the descriptions, and they seemed like this really cool company, but they had this ridiculous tool stack that they wanted. They wanted all of this expertise. I mean, they wanted everything. And I hope they found it. Maybe they found it in some big brain person out of Berkeley or what have you, but a lot of companies really don't know what they expect. They do expect some cost savings. They do expect some tangible benefit. You know, they do expect some improvement, but I don't think that that's always cataloged. And I would really recommend that if you're interviewing for a position, you ask that question: what does success look like in this position at 3 months, at 6 months? Because if you have somebody that's really flighty, they don't know, I mean, you will end up in a world of hurt. I mean, trying to meet some of these expectations that really aren't there. Ivan?
You're saying that 80% of the positions companies that are trying to fill these, are they surprised by this? They put out a position and can't find a suitable candidate? They can't pay someone to help them?
Oh, I have no idea. I mean, yeah, you're hitting, I feel like that's a general software development kind of problem where somebody says, I want to buy 100 steaks for $100, and I went to King Soopers and I couldn't do that, so therefore we have a steak shortage. I don't really know what goes through their head. you can see it, but you can watch them repost and repost.
I have no experience with Python as well, but I'm extremely fluent with Excel myself. And in the former business, I was pulling a lot of data just to get some demographic information and some sales information. I didn't consider myself a data scientist by any stretch of imagination, but the question I want to pose is, what if you're mentioning that 80% of the jobs are going unfilled, how much of that can be addressed with fluency of just Excel without?
I think that depends on how big the company is and how big their data stores are. I mean, if you're looking at being a data scientist for, say, Oracle, I mean, you're probably going to have to make that leap to coding. But if you're looking at, any particular small firm in Denver, you could probably stick to Excel, and they'll have it buried in the job description. I mean, it doesn't usually float to the top; they just sort of assume that you know it. But yeah, it's a surprisingly valuable skill set.
So I'm pretty new, and then, sense background. Excel and SQL, bread and butter, and
Yeah.
seems so necessary. So they're like,
That's true. I mean, I think people are finding that you're really not finding as much out of the unstructured, wild world as you thought you would. You still have to know, select star from, to be able to get what you need.
Well, and I think I have heard that in some of our companies, we have a certain number of people that are coding specialists, a certain number of people that are mathematically literate, familiar with coding, and people that are finance, which makes it hard to
That's a great point, data teams. Yeah, Stephen Jay is our chief data scientist for the city of Denver, so he's supporting me today, and I think that's what he's trying to do, is build a data science team. I haven't yet. Totally will. Yeah, thank you for telling me about that. We have one application that we're working on that's backed by Azure. So, so that might be really cool. Hopefully, I can convince my boss to help me.
So you said that Python and R are the main languages. Are there any other languages as well that are used, or that you use, or are these the new languages?
To piggyback off of that, for Excel and Google Docs, there's a code behind scripting language that you can code your spreadsheets with. And you can allow people with automatically generated sheets, graphs, things that are just created straight from your data set, but you programmatically create them with a code behind. It should be in like data or tools or something on the drop down up there. And it'll have I think in Excel I wish I could speak with more direct experience with it, but there's a programming language.
So we're kind of like the,
Yeah, or manipulating the data that you have, or I made a single cell automata program using Google Docs and the code behind just as a it's robust and easy.
Okay.
Stacey, do you or anyone in the group have any experience of other add-ons to Excel to do like histograms and control charts and exhibits? Have you experienced with that?
So that really perfectly piggybacks off of these two questions, because in order to get to VBA, you have to make sure that you enable developer tools to get to the code behind in Excel. And then you can use add-ons, and Solver is an add-on for both Excel and Google. I saw hands. So.
Oh, I was just saying.
Oh, developer tools.
Why did you look up solver Google Sheets just to like do an add-on from the
Actually, so you can use it with or without. It'll have a linear regression algorithm already there that's like auto-selected for you. You can choose a nonlinear. I was desperately trying to find a model that chose nonlinear, and I could not find one. They're just. Oh yeah, I'm so sure you can. I just. For Mac, for Excel?
Yeah.
It's a good question. I actually dual boot into Windows. Yeah.
I think I also have numbers.
Oh, no. I don't have any numbers, but I'm assuming that it might have its own. Can you just give an example of what types of problems you solve? Data? I mean,
Yeah, let me think of some things recently, because I've been really super elbow deep in SQL. But one of the questions I was asked is how long it took people to process change requests. So when a client comes in and they need to change their employer or their address or something, and they show up in our lobby, or they call in, how long it takes for that data to actually process. And when I looked at the average time, it was looking like it took an hour to process those change requests. Well, when I went ahead and looked at that as a histogram, looked at the modal value, the value that showed up most often, it looked like it would take about a half an hour to actually process those requests. So that, and that, those types of bounds and that type of information is pretty useful to the supervisors on the floor to see whether or not their employees are moving, more quickly than they should, more slowly than they should. There was on the last lightning talk when I was here, there was a woman who presented this really cool look at histograms. Her topic was how not to measure latency in your network. And she had this great picture of safari animals, this great panoramic photo of, giraffes and lions and tigers. And underneath that, she had this amalgamation of all the animals, kind of looking at you. And she was pointing out that average is not an animal in your population. Average smooths everything over, but it's not something that you can just go out and go get. And I saved that because that is something that I, am using to show people, how to read and how to look at their data. That, if you're asking your employees to comply to average, you may be short-sighted. You're taking into account all of the people that can be handled in a 1 minute increment. That's skewing your data over and not really giving credit for how long the process might actually take.
So maybe what would be better is to say 80% of our requests are
within that time frame.
and talk about it. So you guys are doing DHS to try to get your management people receptive to actually using the know, in other parts of the city, we have data capacity.
Yeah.
And data teams, but we don't always have data willingness, in management structure to take that data to.
That's a good point. I mean, I think we, at DHS, we tend to, you know, be pretty willing to air our dirty laundry, you know, to talk about the things that aren't working with our data. We also are struggling, we're kind of hamstringed with dealing with some old metrics that were handed down, and some really smart people at the federal government level came up with these metrics that really don't make a lot of sense. And this is a really, really cheesy thing that I do, but when you're looking at the experience of children going through your child welfare system, when you're looking at whether or not a child is, whether or not you're implementing a new plan to stop a child from being like removed from their family or being placed into what we call congregate care that, you know, that where they're with a whole group of people as opposed to just a foster home or kinship care, which is the ideal placement for when you need to remove a child, you know, so that they are with people that they know, you know, as opposed to stranger care. So there's certain ways you can measure how you're doing. And by that I mean, I can't implement something tomorrow and look at it next week and say it's working. I can implement a new process measure tomorrow, you know, and tomorrow you know, I might make sure that that I'm doing everything, I'm doing my level best, I'm doing everything I possibly can to not put a child in congregate care. You know, but I won't see an outcome, you know, whether or not that child exited a permanency until that child actually leaves the system. So you have to structure your data in what we call an entry cohort. And, you know, the way that that data is structured is a longitudinal view. So you're looking at their placement moves over time, their services that are put in place over time, you know, and the things that we look at as far as how our caseworkers are doing are things like, are you visiting your child every month? Are you visiting the parents every month? Are you putting in services? But I can't measure a caseworker by the kids that are exiting this month. You know, I have to actually, and you have to actually step through the system to be able to do those outcome measurements. So, for example.
So I'm familiar with these stats. I haven't looked. So I'm just wondering, how do you balance out the when you're talking about the amount of time that someone spends and maybe wanting to change their lives? Yeah, the other experience. So how do you combine the two to optimize both sides? Because it seems like we're talking very much about quantitative quality. And I'm just curious.
That's absolutely correct.
That's an issue when I've seen
Yeah.
not just our individual,
Basically, so that process is much more labor intensive, and that's people come back in and review their work. You know, so that's something that that's, you know, harder to teach the computer how to do. We can look at things like how many cases are flagged because they have fraud or the data was entered incorrectly or that sort of thing. But yeah, you're absolutely right. That is something that just everybody struggles with.
So I feel like throughout the city, we kind of have this last year we pull back on customer satisfaction citizen surveys that we just put out. So we can't figure out a way to measure, you know, the quality of the products, some sort of measures that sort of, you know, like the actual results and outcomes are not there. We just always pull back on surveys.
Oh, and I hate surveys because there are two people that respond to surveys, and the first are people that are incredibly, amazingly happy, and they're the minority, and the second are the people that are amazingly irritated. And, yeah, so.
I mean, isn't that a great way to sort of discover the bumps in the process anyway? Because people are mad about something,
Yeah,
identifying that something.
no, and that's true. But you will find people unfairly taking out their yayas on your employees. Oh my gosh. You do customer service for Verizon. Yeah. So I was at Comcast yesterday, looking at their data. Why I don't know. They're out of all people. So I answered this phone call, and this woman found me through Women Who Code, and I just I answered the questions that she asked me, and I think I made an inappropriate joke, and I hung up the phone, and then I Googled her name, and she was the VP of Business Development. So, right on. And amazingly enough, she invited me back to kind of take a look at some of their analytics, which was really neat. It was a fun day, but there was one customer that, I kid you not, issued up 500 complaints in the last 2 weeks. And I was like, either they're a bot or they're unhinged. And you need to just say, keep your modem, we're calling it good. Like, don't let this person into your building. I mean, so I was going through, and so what they're doing is they're putting Hey Dupe on SQL. And so some of their people do not know SQL. And so it was actually kind of cool to, break out the whiteboard and start teaching them. And it's funny to me because I always think of statisticians as being like so advanced, and ready to code, and they can be surprisingly timid about it. Like, you have read-only access, you are not going to hurt anything. So that was a different experience.
Yeah, I think we'll wrap it up, and we have the room for 10 more minutes, so people can mingle and ask questions to each other, not just to Stacy. But thank you for coming.
Yeah, thank you for coming.